In today's video, we'll be looking at the area of a triangle, specifically a non-right angle triangle. We already know the area of a right angle triangle is A is equal to half times base times height, or half BH. Now today it's different. We're looking at an NRAT, and you may note we're using the terminology or labeling of the triangle that we did the other day when we looked at the sine rule and the cosine rule. So we've got vertex A here, right, and we use a capital for the vertices, which also represents the angle inside here. Opposite our big A is a small a, and this represents the side length. If we go through, we also have angle B here, which is also vertex B, and the other side is that B there. So this is small b, and then the very last one, we've got angle C or vertex C, which is shown here as being side C. So we use this terminology instead of our area is equal to half times base times height. So base in this case doesn't necessarily mean it's the base of the triangle. Now, how does the formula work? Well, I like to think of it as if we know one side, another side, and its angle, i.e. an angle and its corresponding sides, then we can work out the area of that triangle using this rule here. So it can come in three flavors. You can either have it as A is equal to half AB sine C, A is equal to half AC sine B, or A is equal to half BC sine A. What that really means is, and I'll do this in different colors just so I can highlight what each one of these means on our diagram, in yellow, is half AB sine C means we know A, B, and sine C. So in blue, I'll show you that one. So if we know those and the internal angle C, then we can use this formula. If we know these, side A, side C, and angle B, then we use this formula. And if we know angle A, side B, and side C, then we use this formula. So off we go. We're going to calculate the area of this worked example, then pause the video, have a go at the your turn, and then play the video to see if we got it right. So let's label our triangle first. A, B, C. It doesn't matter which letter you start off with. And then we label our edges. So opposite our big angle A here is going to be small a, which is the side length, B, and C. So now we can see that we've got an A, a B, and a C, very much like our green equation here, A, B, C. So we're going to use our green equation. And then we substitute. The area of this triangle is equal to half times by A in this case is 10, times by C, which in this case is 9, times by sine B, which in this case, B is 29 degrees. Now we reach for our class pad, make sure we're in degrees, make sure we're in decimal, and then type in 1 on 2, or you can do 0.5, times by 10, times by 9, times by shift 1, 29 degrees. Enter. And we've got the area is 21 point, and this says 2 decimal places, so go to the third decimal place. It's a 6, so that'll round up our 81 to become 82. And then our units are centimeters, and since this is the area, centimeters squared. And there we go. We've used our formula to find the area of a triangle. Pause the video now, have a go at the your turn on the right, and when you think you've got it, press play to confirm your answer. The your turn will start now. We've got the same triangle over here. I label the triangle vertices A, B, C, and then label the sides like so. Now we know we've got side C, we've got side A, and we've got angle B. Now which one does that match up with? Well, I go straight to this one here because this one uses our angle B. So we're going to use the same formula again. A is equal to half times AC times sine B. Sub in our values. Half times by A, which is going to be 9, times by C, which is 7, times by sine B, which is 107 degrees. Evaluate. Now I'm just going to reuse this equation from before. 9, 7, 107, and we get 30.12. Now, what's our units? It's centimetres again, squared. There's our answer. In the next video, we'll be looking at how to find a side or an angle when we're given the area.